and I'll be sort of giving the introduction to the both AI and ML. And since it's all under one umbrella of AI, so I just put the title slide as AI. And since it's an online class, I would expect that there will be a two-way communications. So please feel free to ask questions. Stop me at any time. You can use also the chat box, and so we can discuss and proceed as the things progress. Okay, so overall, my idea of today's talk will be sort of partitioned into these areas. So I will look at some applications of AI. We'll not go into details, but we'll look at some knowledge and data representation. So please try to understand the term knowledge here. We are very much familiar with data. Now, from the data, we are trying to create a knowledge. So there has to be an issue of analysis and interpretation of the data that converts data to knowledge, right? So we are talking about knowledge representation vis-a-vis the typical data representations that we are familiar with. We'll look at some machine learning issues. Specifically, we'll look for pattern recognition. What is pattern recognition? Again, given a specific behavior of human understanding, given a set of data, what is the underlying pattern? What is the underlying system in the process? And we'll call that as a primitive form of machine learning. We'll look at what unsupervised machine learning is, what supervised. I will go into the details of these terms with applications as and when it comes. And finally, I will not be having much time, but just raise few concerns about both ethical and social implications. Again, you have to appreciate the fact that these are the typical semester-long course, and we are trying to squeeze it in 2 hours. So there will be some gaps. Please take note of it. Go back to the fantastic tutorials available in the YouTube. There are books, right? And feel free to learn at your leisure or at your requirement. But this is a vast area that we are trying to explore in a very small amount of time. Again, please feel free to raise questions if you have. I will start with a very classical definition of AI, artificial intelligence. It studies representation and manipulation of knowledge. Once again, stress on the point knowledge. It's not data, it's knowledge, such that a knowledge base may be created for a given application. And we are amazed with different kind of applications. AI-based interface extracts human-like inferences from the knowledge base. So it's a human-like inference. However, given that a computer as of now is primarily a number crunching machine, and that's where the bottleneck lies. Computers understand only the number, right? So whatever you do, whatever human-like inference that we are familiar with, it's completely unknown to computer even as of now. So we need to understand at the end of the day, this knowledge is in the form of the data, and computers are happy with the data. Computer process this data and generate the human-like inference. So that's it. Essentially 3 key points in these slides: knowledge, human-like inferences, and the bottleneck about the number crunching capability of the machine. And it's kind of a limitation to the entire process. So probably you've heard the name of Alan Turing. Just 2 days back, it was his birthday. The famous award in the field of computer science is also in the name of Alan Turing, Turing Award. And Turing has designed a fantastic test actually to test an AI system. So it is as if there is a room, and in the room there is a partition wall. On one side there will be a human being, the other side there will be a machine. maybe a robot, maybe an algorithm, and that human is going to ask several questions to the entity that is on the other side of the partition, right? And which we'll call as AI, provided that the machine on the other side or the algorithm on the other side can fool the person, the real person on the left hand side, right? And that's what the Turing test is all about. So given an algorithm, I mean, we can always ask, has it passed Turing test? What is the state of the art? Well, in some cases, yes. Some cases, AI is doing fantastic work. And very surprisingly, for very complex systems, AI passes the Turing test. Let's take a game of chess, right? The other side, there's a machine. So someone is playing against an AI algorithm playing chess. And maybe that AI algorithm beats that person. So that AI algorithm is winning the Turing test. But for even simple applications, can it recognize a cat? Can it recognize a dog? Maybe it is going to fail, which human being can, does at ease. So that is the paradigm, or that is the conflict of paradigm in this case. For complex systems, AI is maybe very good in some cases. For a very simple rudimentary inference that human being can does, AI fails brilliantly. And so there's a famous textbook on AI. So if you're interested, Charniak et al. Has a book on AI if you wanted to study deeper details on different aspects of AI. And they have defined AI in a very simple term. It is the study of mental faculties through the use of computational models. So computation models essentially runs on the number crunching machines. And number crunching machines cannot compute on mental faculties. So you need to convert the mental faculties to computational models. And that's what we're going to look at a few cases. Is there any question so far? Okay, some of the very popular application areas that we look at, one of the very popular one is the predictive data analytics, speech processing. So on the other side, if you think of the Turing test slide, on the other side, there is a computer with which you are talking. Maybe you want to book, so it's you go back to this slide. On that AI block, there may be an algorithm running, which is talking to the customer who intends to buy an air ticket, right? And that algorithm is actually talking to that person and giving the best option of which flight to book, what time of the day to book, etc., which hotel to select, etc. So it's doing an automatic speech processing, which can infer, which can communicate with the user. Natural language processing. So just like a human being, letter is getting drafted, you will be exposed to LLM, large language models, which can actually summarize maybe a research paper. It is going to summarize a few seconds and give you the key content of the paper. This entire talk of 2 hours are actually recorded by Zoom, and Zoom is going to give you an AI content generation, give you the gist, right? We have a very low attention span today. So it's actually processing my audio and generating a sort of a compact content or abstract of the talk. Computer vision, will come to that. So just like our human eyes, can a computer algorithm recognize an object? Can a computer algorithm differentiate between a cat and a dog? It's a very difficult problem, which is so simple for a human being. Robotics, industrial control and inspection, communication system. So we'll see a few of these examples in detail and we'll go into the details. So last slide, we saw the broad application areas. Let us take some specific examples and where these kind of application areas that we just discussed can be addressed, can be grouped. So let's take the first question. Is this a cancer? So, so a person has, let's say, pathological report. A person has biopsy report. This person have radiology reports. A person has the clinical reports. A doctor has seen the patient and got the clinical information, age, height, body weight, body mass index, etc., etc. So all these informations are available, and then an expert oncologist comes to a conclusion. Is this a cancer? The oncologist answers that question. Now, go back to that Turing test slide. Now, an algorithm is looking at the same set of data. The algorithm is looking at the radiological data. Algorithm is looking at the histopathological data. Algorithm is looking at clinical data. You give all this data to the algorithm, and can algorithm answer this question, whether this particular patient is suffering from cancer or not? Or can the algorithm assist doctor to arrive at a very concrete decision about the malignancy or the benignness? And that's where the AI comes in. That's where that human-like inference, expert-like inference is coming. What is the market value of this house? So a particular region X of a city, you have past data of 10 years. And in past data of 10 years, you have the information of the house, how many rooms are there, how many bathrooms are there, what is the age of the house. You have all the details. And then from the past data, you know that at what price these houses are sold. Given these, can you estimate the new house, an unknown house, what would be its market value? Is this fairly clear about these questions that we're trying to answer? If you have any quick questions,
এই দেখো আমার ভিডিও স্টপ বলছে করে দে ভিডিও স্টপ বলছে
can you please mute yourself?
Can you please?
Yeah. Which of these people are good friends with each other? Can any one of you name an application where these questions are being answered regularly? Which of these people are good friends with each other? Facebook. Maybe most of you have Facebook account. So Facebook is recommending the friends.
Yes.
Right? So exactly, Facebook is trying to find out which one of my user may go with which one of the other user. If you buy a red T-shirt in a particular website, that website may send you feelers to buy that blue T-shirt or that kind of particular product or a coffee mug, and etc., etc. So it's kind of an association or link that that engine is creating so that they can answer these kind of questions. Will this person like this movie? Can any one of you give me an application that you know where it is being done? Will this person like this movie?
Netflix, we can get to
Netflix, exactly, yes. Netflix continuously recommends once you start using Netflix movie, and then based on your choice, your genre of choice, maybe comedy, maybe romantic, maybe horror, it has gotten an algorithm is being run automatically, which is going to give you the next recommendation for the choice of movie. Who is this person? You're trying to answer this question, human-like inference. You identify a person. In other terms, these are called the biometric. So given the person's face, given the person's eyes, color of hair, color of eyeball, etc., etc., you identify the person. Has anyone any application in mind where it's being done? So if you fly through airports nowadays,
Yes, has scanner in the gate, your identification
so
scanner.
that's right. So DigiJatra app, the entire DigiJatra
Yes.
app is actually based on this biometric. It is recognizing you, right? So that means at the gate of the airport, your face is being scanned, and that face is being matched with the face that you have given in your Aadhaar card. So again, going back to my earlier slides, that algorithm, that software instantly identifying the person, generating a human-like inference. And these all are the questions that AI or machine learning algorithm answers. So overall, whatever we have seen so far, any question, by the way? So if you have any questions, please. So there are two.
One question.
Yeah.
So these algorithms must be set by with the help of programming, I guess.
Exactly. Yes. So
So
computers are number crunching machines, and we all study AI, machine learning algorithms to build these softwares, these computer programs. Yes.
my question is, sir, how does it it acts like a human-like inference? For example, in computer programming, if I consider it based on commands, right? So it can also give information like a human, like as if I'm talking to a human. So
Yeah.
all these things are also put in as a kind of commands to the computer.
That's right. It's a command which are processing data, right?
Okay.
So in that DigiJatra app, where the person's face are being identified, recognized, so all the geometry of the face and the color information of the person's skin, eyes, position of the eye with respect to nose, the lips, all these are being scanned, right? These are actually forming a set of data. And that data, because the computers are ultimately are only happy with the data. So a series of commands are there in the computer which will process this data and generate the inference.
Okay.
So it will be more clear if you look at this slide. Where I call this slide as a, how to learn a machine. So here is a black box S. S stands for the system. So objective of an AI engineer and an ML scientist or a data scientist is to build this S. And S is going to accept X, and S is going to infer Y. Y inference should be human-like inference. Identifying a person, identifying that whether it's a case of cancer or a benign, identifying Y as the market price. If you ask the question, is it going to rain tomorrow? So S is that system, a model, which will predict with certain probability that tomorrow there is 80% chance of rains. So why is that 80% chance of rain? And what would be typical X for that S? Can anyone guess? So X typically would be, let's say, last 10 years of data. So what happened in 26 June on the last 10 years? You have data of the rainfall of 26 June for last 10 years. These are numbers. You have data of humidity. You have data of temperature. You have data of wind speed. You have data of wind directions. So you have all these X's for over, let's say, last 10 years. And you build a mathematical model, a computational model S, such that if you ask S, is it going to rain on 26th June? Is it going to rain on 27th June? Y should give you an answer of, well, there is 60% chance of precipitation, 50% chance of rain, etc., etc. Is that clear?
Yes, sir.
So you can think of that model. I mean, most of you are teaching, subjects related to mathematics, I would say. You can think of these are typically called the regression problem. So let's say these red dots are those informations that you practically collected for last 10 years. Let's assume that. Okay. So and then you plotted those red points. So these red points are X. So let's say I'm going to predict this, I'm going to answer this question. Is it going to rain tomorrow? So I have collected past 300 data points on 26 June. On 26 June for last 300 years of data, assume that I have. So I have data of rainfall on 26 June along the x-axis, and along the y-axis, I have the temperature information. So there are 300 data points. Each data point is a two-dimensional coordinate, x, comma, y. What is x and what is y? I just said. Can anyone repeat?
The temperature as well as
the
Temperature
inputs which
along-
are required for
Tem-
the prediction.
temperature along y-axis.
So
X
X
is
is
the
the
last.
rainfall and
Rainfall.
Y is the temperature.
X is the last 10 years data of rainfall,
right.
and Y is
Well,
the predictive
if I just
value,
consider
so
26
whether
June,
it will go.
yeah. So X is the data of rainfall on 26 June, and Y is the temperature data for the 26 June. That makes these red dots. Then what you naturally do, you try to fit a best fit line, and blue is that best fitted line. So it's an approximation of the points using a linear function. So S is that linear function. S is that black box, which is represented by a line equation. And we all know the equation of the line. Y is equal to mx plus c. So you can say it's an estimation problem where you are estimating the gradient of the line, slope of the line, based on the past data. Is that clear?
Sorry, is it like regression analysis and prediction?
It's a simple regression analysis. Yes, it's a linear regression.
Okay.
And then
Okay.
what happens is, what happens on the 2025-26 June? That is nothing but extrapolation of this line. I have data till 2024 of 26 June, but I don't have data of 2025-26 June, which is tomorrow. Right?
Sir, here the independent variable is temperature and the previous year rainfall, and the dependent variable is what is the going to be rainfall tomorrow.
That is right. I mean, that's just my rudimentary example, simple example. So I mean, you can take any x and any y as per your application. And therefore, based on the slope of the line, you can predict what will happen tomorrow or day after tomorrow or on 30th June, right? So that's how you can predict. And you can say, I have learned the model. I have a computational model now to predict the rainfall pattern for the entire month of July based on the slope of the line. Is that clear?
Sir, I have one question.
Yes.
I am teaching physics. So,
Yeah.
like for example, we also get to have a job to do, like we have to predict like what can be the question pattern for the next year for the class 12 or JE or NEET and like this. So AI can also work on that, like it can get the data from the past 10 years or 20 years, and then it can also predict what kind of like question pattern,
Well,
or not question pattern, not the standard.
I understand that. My answer, it cannot be yes and no, but you look at the challenges of the problem. This particular problem, if you have understood, can you tell me the challenges of this problem? Where are the critical issues in this problem in estimating the future data?
So in this case, the question prediction case, if the syllabus is changed slightly, if the question pattern is changed slightly, the number system, what the changes occur during the period?
Yes. So yes, I mean, exactly. So you're very close to it. So you can see I have fitted a line here, right? Now, maybe the problem that you were saying about predicting the question pattern, first of all, what kind of features you are going to take? In the rainfall pattern, the physics or the features, characteristics are well defined. I know that I have the rainfall pattern information. I have the temperature pattern. I have the humidity information. I have the sort of wind speed and wind direction information. So I know specific features based on which rainfall pattern can be predicted. Do you have those specific features of predicting the questions?
Yes, sir. Blueprint will be the specific feature, like from each unit wise, what is the marks distribution? So that will be fed into the system.
This could be. So if your feature choice is good, your prediction will be good. If your feature choice are bad, your prediction will be bad. So just like an expert oncologist, right? Expert oncologist will immediately infer the case of malignancy versus cancer based on the radiological data, based on correct interpretation of the histopathological data, because the expert oncologist may have fitted an equation like this mentally. If your features are wrong, if you have not taken the correct feature, and you want to predict, it may not be right. So it's question to answer your question, whether when I predict the question pattern, the issue that comes is that what are the features based on which question patterns are actually developed? If you know that, then it's perfect. But if you can't discover that feature, that characteristics, is that sort of clear?
Yes, sir. Yes, clear.
There is also a singularly important problem in this case. You can see the model S that we have built is a line. There's no guarantee it would be linearly related. It could be non-linearly related as well, right?
Sir, it was my question. I am not asked to bother you.
Yes.
Why we should take a linear instead of a non-linear?
Yes, exactly. That is the question. That's so. So given the situation, it's sort of the expertise of the data scientists or the AI engineer who will choose the model. I choose to fix line. Maybe in some applications, line will not work. You have to do a nonlinear approximation, right? Let's go to the next example. And, slide is not moving. Yep. What is this? Often we see this situation, especially in this month of June and July. We predict our IMD, India Meteorological Department, predict the movement of the cyclone, right? And they are fairly accurate. They could predict exactly from where the cyclone is going to pass, where it is going to hit the landmass. So if this is the position of these of the cyclones at different instants of time for last 2 days or 3 days, then you can see clearly you cannot fit a line here. You have to fit a nonlinear model. In fact, the specific model they fit is a log spiral model, a spiral kind of shape. So instead of a line, you fit a spiral. Now, again, I'm sure maybe you are not exposed to how exactly a log spiral model is fitted, but take a note of it. Please study the regression in details, where the idea is, given the data, you try to fit a model, a mathematical model. So what could be the x-axis and y-axis for this particular application you can think of? You are trying to predict the position of the cyclone maybe on the 27th June, given the data up to 25th June. So what are the data? In the last problem, we have taken one axis as the rainfall, the other axis is temperature. So here, what would be the x-axis and y-axis?
X-axis will be the time, y-axis will be the position of the cyclone.
Right. X comma y, the coordinate of the eye maybe, right? Coordinate of the eye of the cyclone. So it may be a three-dimensional space. Time is one. X and y are the coordinate of the eye of the cyclone. So you actually fit a surface rather than a line. If there is a problem in communicating, understanding, please ask questions. I'll be happy to try to address those concerns. But certainly, as we can see, it's not a linear fitting. It's not a line that we are fitting for this case. So what are the typical
because
X and
the eye of the cyclone is itself a two-dimensional, X and Y.
X and Y, exactly,
and,
right.
And the other dimension is needed, that is time.
Time, that's right. Very good, yes. So you fit a surface rather than a logarithmic spiral surface. It's a bit complex mathematical equation, but then computers are always happy to work with these numbers and equations. It's a number crunching machine. So if I go back to this black box question, from these two applications, can you tell me what is X, what is Y, and what is S?
X is the previous year data, like say temperature and the rainfall that we are fitting in till 2024, and the Y is the prediction that we want for that, say for the tomorrow rainfall.
Extrapolation, yes.
Yes, and the S is that is the it may be a linear equation, it may be some equation that is going.
Fantastic, linear and non-linear. Yes, that's right.
Yes, sir.
So the responsibility of a machine learning scientist is to design that S. X is given, you choose X, subset of X maybe hundreds of data are available with the India Meteorological Department. But I choose that particular subset for my application. So choice of features is very important, choice of X and design of S. So these two are the primary responsibility of an AI engineer. I think I'm clear till this point, right?
Yes, sir.
So others, yes, we have to make sure that I'm not speaking Chinese and you don't understand anything.
No, sir.
So please feel free to question, because there's no way to know that how you are responding to my understanding. So let's take, I was talking about that question that what is the price of this house? So given a particular region, a particular, a borough of Calcutta city, and you were saying, okay, what could be the price of this house? Well, you rely on the past data. And there is a typical data available in the web for Boston housing data. It's very well known Boston housing data. You see, these are the different characteristics they have taken. The first column is the total value column. So this total value is what you are going to predict. So this is the Y part, okay? And then you have this tax, square foot area, in which year it is built, gross area, living area, number of floors, room, bedroom, full bath, etc., etc., etc. So these are those features that we have just discussed, those X. All of these are X. And it's multidimensional. It is not two-dimensional or three-dimensional. It's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 dimensions. You can't even visualize on the screen. You can't visualize more than 3 dimension or 4 dimension. So in fact, you will have classes on the visualization tool. That's why the visualization is very important, because you can't build a model. You can't build an AI model if you cannot properly visualize it. If you go back to this problem, if you can't visualize these with an image, you don't know whether a line is to be fitted, whether a curve is to be fitted, whether a log spiral has to be fitted, whether a circle needs to be fitted. So you need to visualize it. And in a data set like this, it's very difficult because it's 12 dimensional. And typically these LLM models and other tools that you will be exposed in these 2 days, you will see the data, the feature set may run into hundreds and thousands. So again, my question to all of you is that using this data, which column are you predicting here?
Total value.
Total value, right. So total value is that dependent variable.
First column.
First column, yes, yes. And others are for a new house, you fit in these information. What is the tax? What is the square feet? How many full bath? When it is remodeled, etc., etc., and then you predict the total value. Here is another data set, just to give you an understanding of different flavors of the problem. So here, let's assume this is a data collected from a bank. Bank gives credit or loan. So for a given applicant, the bank manager asks this question to the software, to an AI model: should I give loan to this person or not? In order to arrive at that answer, that should I give loan or not, which is actually shown here at the last column, you see the class, yes or no. Yes means the loan is approved. No means the loan is not approved. So to arrive at the decision, the bank manager will ask 4 questions. And those are given in the first 4 columns. So the first column is age, and bank manager has divided into three groups: young applicant, middle-aged applicants, and old-aged applicants. Whether that applicant has job, true, or does not have job, false. 2 characteristics of has job. Own house, whether they have own house or they do not have own house, true or false. Credit rating, fair, good, excellent. And based on these 4 columns, therefore, you predict the fifth column, which is yes and no. Is that understandable?
Yes, sir.
Yes.
So for a specific bank, let's say I have data for the 15 such applicants, and I created the model. And then the 16th person comes in, 17th person comes in. I will feed these first 4 column information to the system, and the system will give me what?
The decision whether to give loan or not.
That's right. So you go back to that
column,
block.
5th column.
That's right. So you go back to that system modeling case. X is what then for this credit problem? How many dimensions X has?
4.
4 dimensions, right? 4 dimensions. 4 dimensions. So you have age, has job, own house, credit rating. And what is the Y?
Loan, yes or no?
Yes, yes. Y will have only 2 values, 0 or 1. Yes. 0 and 1. Yes and no. Now, is this 4 good enough for the decision, or I need another 4? That will depend on the experience of that modeler. If you have better features, if you have less features, all depends, will actually can be measured that how good the system is. Is it doing a human-like interpretation? So you can see that the first slide definition of AI, we are saying that you do a human-like interpretation. So who is the human here? Bank manager is that human. So bank manager can take decision manually based on this information. Instead of bank manager, based on this data, a computer model S is going to take the decision, yes and no. So is that analogy is understandable?
In this way, we can sometimes try to eliminate the human bias.
Oh, excellent. Sir? Yes, perfect. Yes, yes. You can actually eliminate human bias. You can answer if someone is refused, then you can clearly answer the question why he or she, as a loan applicant, is refused. Because it comes out from that mathematical model, from that statistical or computational model. We are not, remember, yes, here, it's not exactly this line fitting problem. It's a little bit complex problem, and we are not discussing how these 4 columns will be integrated into an S. We are not discussing it. If you're interested, write it down. Decision tree is a very good model. Decision tree. Please study decision tree. I think in some CBSE syllabus, they also include decision tree nowadays. I think so.
Binary tree.
Binary tree, yes, it's a binary tree. It could be ternary tree. But what I am specifically focusing is on decision tree. Here we are making a decision. And the final decision is yes and no. That is, by chance, is only binary. So you can actually
rule-based learning, sir. I think you can say it
right.
as a decision tree.
It's a rule. You are creating a rule. Fantastic. Right. And how you are creating the rule? Based on the decision tree. You can automatically generate the rule. Okay. So please study the decision tree algorithms. I'm not going into the algorithmic level. I'm just giving you an overview. So here is the S. S is the decision tree. X is these 4 columns. Y is the output. And the fancy name of this entire thing is called the AI model, or the machine learning model. I'm ready to wait for a few seconds if you have any question. So overall, now we can go into a little bit details on this representation of the knowledge. So these 4 columns just discussed are the representation of the knowledge. This entire table is the knowledge base. And you are doing an inference, a knowledge inference that you are doing. What is the inference you are doing here? Human-like inference. In the last example.
Whether the person is credit worthy or not. Loan
That's
worthy.
Right. Yes and no. Yes. So for example, in the rain, is it going to rain tomorrow? The inference is yes or no. Maybe with certain probability. So these are the typical areas of AI that we need to go into this. These are some of the side issues. At this moment, I'm just ignoring it. I will come back to that if time permits at the end. Ethical issues, why the ethical issue comes, environmental issue, why the environmental issue is come, and why the privacy issue is going to come. So naturally, you can see that we are working with a set of data. Let's say I have set of data, these loan data collected from a very affluent community, right? And I take that data from an affluent community and trying to apply that for a community which is very low paid, underprivileged region in the area. So is that model correct? And there is a great debate on that. That should not happen, right? You should have a very focused model in this case, keeping in mind the neighborhood from where the data is collected. So there is an ethical issue of applying the model all across for all communities. So this is just an example of ethical issue, but there are many complex and deeper issues involved in the ethical issue. Environmental issue is that huge amount of power, huge amount of energy is now being spent to train this kind of models. I'm giving you some toy examples, laughable examples. But today's chat GPT kind of models where you are developing these rules may take energy in the level of gigawatts, right? Maybe energy used in a city for per day will be required to train a model. So you need a huge amount of environmental impact. And this is really, really a concern. And we should be aware of it. And you need water. Why you need water? Because you have to cool the system. The cooling system is highly, highly sophisticated. And the amount of water it needs to cool this training system, the computers, because it's not 1, 2, 5, 10, 20 rules. We are looking at 20 billion rules. So 20 billion rules running in a network requires huge amount of power. And that power is a concern for the environment. Privacy issue. Should this data be made public? Should this data be accessible to all? And as I can see, I mean, as all of us can see, the data is not private at all. It is, especially we go through a very loose regime of this data. For example, this loan data, the credit worthiness. Should my credit worthiness be public? Can anyone just go and get it? These are some of the privacy concerns that bothers us, all of us, and we are not getting into the details of it, but I just mentioned it to make yourself aware of that. Any question, comments?
So just like we now everybody is trying to remodel, like for example, very easy example if I take, we are all accustomed with petrol and diesel car, and slowly we are moving into EVs, so that we can reduce the pollution and all, because the heat dissipation is a major issue. Wastage of energy is a major issue here. Correct. In AI. So correct. Now work has to also be done on that, how we can reduce the wastage of energy using AI as well, because right. AI now has become a part of our daily life, like not daily life, like in each and every model. Yes. We use have to use. Yes. So is that kind of
this use of EV reduces pollution is also a myth. It's not true at all, right? These electric vehicles runs on what? Electrical energy. So somewhere right. This electrical energy is being generated.
Yes.
So this is just a foolish idea that EV reduces the pollution. It just shifts the pollution. It manages the pollution. So pollution in Calcutta may be reduced, but pollution in the place where the power is getting generated, maybe a thermal system or a nuclear based system. Yes. So it's actually shift or reallocation of the energy wastage. Not wastage, I should say. I should not take the term back. It's a reallocation of the pollution. So there are environmental issues. Anyway, so let's go deeper into that. So we have seen the knowledge representation, knowledge base, knowledge inference. I hope there is no question on these three parts.
No, sir.
We are not talking about data. Please understand the difference. Not data representation, not database, not data inference. It's a knowledge inference, knowledge base. But remember, having said that it's a knowledge, we have to understand the computers are only good for data. Computers are not good for knowledge. So your algorithm should convert the data to knowledge. Computers at the end of the day are familiar with data structures, some logical constructs, symbolics. Those who know computer programming here, they know that what is an array, what is a linked list. And here also we have to use the same thing, same array, linked list, data structures, some attributes of the data to represent the knowledge. Because we are representing data. At the end of the day, it is data. Computers are happy with the data. Similarly, to knowledge base, we are actually creating a rule. So someone has already pointed out, for that loan system, we are creating a rule that if you have a job, if you have your own house, then the loan will be given. If your credit rating is fair, loan will not be given. So you are actually creating a set of rule. Not only rule, you are creating rule and exceptions. All birds can fly. Sorry, let me restructure it. Some birds can fly. If the bird has wing, it can fly, but emu cannot fly. So you're creating a rule and the exception. Emu is a bird, it cannot fly. Emu has wings, but emu cannot fly. So you are creating that rule base through this process. So in medical understanding system, in medical assistive system, again, the idea is same. You have these certain histopathological characteristics, you have these radiological features A, B, C, then it is this kind of problem, this kind of ailments. So you are actually creating a rule based through this process. And finally, we'll do an inference based on that rule. Because rule
Sir, I have a query. So,
yes.
sorry to disturb you.
Yes, no
So
problem.
it means rule-based, we are setting the process. We are explaining the process. We are instructing our machine how they will process. Right?
Right. So computer programming is going to create these rules. Okay. So if you go back to this problem of this drawing this line, you are estimating M and C. So your computer program is going to calculate that M and C by fitting the mathematical model. Okay. So your rule in this case is the generation of that M and C. The slope and the intercept.
Bye.
Is that clear?
Our computer programming will estimate M and C.
That's right. Yes.
But
you have an a priori. If you have an a priori model, you said that there will be a linear fit. If it is a log spiral, there will be something else to fit.
Okay.
If it is a circle, then it is going to find out the radius, and then you get the circle x square plus y square is equal to r square. You put that equation in the set of data.
Sir, are you talking about y equal to mx plus c, the gradient and y intercept?
That's right, yes.
Okay.
Yes. So y is that output from the black box, x is the input, and the box is going to create that M and C. But your computer program is going to estimate that M and C. So take an example of this path estimation problem between source and destination. It's very common. We book these app cabs and we go from point A to point B, and that app cab charges 300 rupees, 500 rupees, whatever may be. So what the app cab, that application is doing, that Ola, Uber, etc., it is actually estimating that path between the source and the destination, right? Which is known. There are the maps are known. There is nothing intelligent about it. It's the data that is available. But what additionally they are looking at is what is the shortest distance between point A and B. There may be multiple paths. Out of the multiple paths, it's going to estimate the shortest path. It's going to look at the path which has got less traffic, less congestion. It is going to look at a path for which there is a less amount of toll. And path may be dynamically updated also. So today there is a path, and maybe tomorrow there will be some construction work going on, that path is closed. So dynamically the map is going to be updated. So all these, and maybe many more, there could be business secrets as well. Based on that, they're estimating the cost between the source and the destination, right? So a computer program, an AI program, is estimating the cost between point A to point B if you hire a cab based on these characteristics, these features, these attributes. Am I clear about the challenge? So then we can map this problem as a, if you know the term graph, as a data structure like graph. If not, I would suggest you to go through, there are again very good tutorials on how to represent graph, how to represent trees, right? So please study a little bit on the graph. You will have a fairly good idea. And whatever I just said about path estimation, you can map that problem in a path, in a graph structure like this. So if you look at the slide carefully, the point A is 0. And you want to go to point 4, the node number 4, 0 to 4, right? In a city. And going from 0 to 4, you have multiple paths. You can go like 0, 1, 2, 3, 4. You can go 0, 1, 7, 8, 2, 5, 3, 4. You can go 0, 7, 6, 5, 4. You can go 0, 7, 6, 5, 3, 4. You see hundreds of such paths, right? And if you take that path, you can estimate a cost. And the cost could be based on these: shortest distance, therefore less amount of fuel will be required, whether there are traffics or not, whether there any toll has to be paid, whether the road conditions are good, right? Whether it's a highway or it's a state road, etc., etc., etc. And based on that, you find a cost. Let's assume these costs are some unit of course as 4, 8, 11, 14, etc. So you map these.
Sir, one question. For this, it's the same distance. When it's peak office hours, since it is less traffic, it is more costly, and the lean time, it is less costly.
That's right.
Because, okay.
But whether it's less costly or more costly, I don't know that. I do not work with the Ola or.
No, sir.
So they have the business secret. That is true. They have the business secrets there. So how they assign the cost is purely their business interests. But they keep in mind these characteristics. And maybe there are other points also which I don't know. That only that these people will know, right? Go back to my black box S. So they are modeling S. And how they're representing X. So X, Y, S. Go back to that understanding once again, right? So X is those informations: congestion, day of the time, whether it's raining, whether the road condition is good, whether the toll has to be paid, is it a national highway, is it a state highway, etc., etc. And using S, what is the S? I am saying the S will be a graph like this. S will be a graph like this. If you don't know graph, please study graph. It's a kind of architecture that we use for capturing the data. And then why is that inference? What is the best path? So if you could understand the problem, that itself I think it's a good credit for this class. How to solve it is a different issue. There are many ways to solve this problem. So by the way, you can write down the Dijkstra shortest path algorithm. That's a famous algorithm. The Dijkstra has developed. Dijkstra has a mathematical technique to solve the best path given a graph structure. So whether from zero, there is only two paths. Either you take path through 1 or you take path through 7. Should I take 1 or should I take 7? So this can be solved using a Dijkstra shortest path algorithm. I'm not discussing the algorithm because that cannot be covered in details. That itself will take one class. But this is how you can map a potentially AI problem and solve it using the shortest path algorithm. There are algorithms for heuristic search, So heuristic search, heuristics, as the name suggests, is that you can take, it's sort of like the way the human being takes a decision. So human being generally takes a decision using a divide and conquer strategy. It's a difficult problem. So I take a baby step. I solve the problem as a baby step and then go to the next position. And then I take again a baby step, then again a baby step, and divide the entire problem into a kind of divide and conquer policy. So you start from S, your destination is G. You first decide about A and B. Do not think anything else. And then once you're at A, decide about C and D. Similarly, once you're in B, if the B is the choice, then choose between E and F. So you take an heuristics, a local heuristics, and take a decision. I'm in North Calcutta, I have to go to a point at South Calcutta. I will first go to, let's say, Shambhajar. Up to Shambhajar, let me take a call. Let me take the best path. Then from the Shambhajar to College Street, I will take another path. So you have an heuristics based on which you take a decision. So the road characteristics conditions from here to Shambhajar will be one. And then from Shambhajar to the next stop will be another one. So I take these entire problem, divide it into sub-problems, and consider each sub-problem as a divide and conquer strategy. Is there any question so far? I'm not giving you
what is the right part of the heuristic model? The tree we have understood in the node and H, A12.
So from the S, you wanted to go to G. Right?
Yes.
So naturally, as I can see that I should not take the path A.
Yes.
But that path A exists. I can go up to C and D, but there is no path up to G, right? So
yes.
So that way here in more of it is deterministic. Standing at S, you cannot your choice would be both A and B because you don't know what happens next after A and B. But coming at A, you may be at loss because
yes.
you can't go to G. So you have a wrong move in that case. So heuristics is a kind of a temporary decision making at that point. Sometimes you will gain, sometimes you will lose.
And what is H? H is a
H is another node. H is another destination. I is another destination. Right? These are the nodes. But for this problem, I say, let's say from S I have to go to G based on certain local characteristics. Baby step I'm going to take and take a call. So there are heuristic search algorithms. So if you're interested, go into the heuristic search algorithms and you can study that. That's just like this Dijkstra shortest path algorithm. There is also heuristic search based shortest path.
And B, there can be EF for E1. Yes. Oh, and F there is 2. That's why B H is 4.
Yeah, but each time you see sitting at when you are at B, you don't know whether through E you can reach G or not. You don't know that because you are taking a small step.
What is the value of H? What is the column H represents, sir?
Column H is a heuristic value. If I take that baby step, what would be my cost? Right?
Okay.
If I take the baby step, it may be right, it may be wrong. The high cost means I pay more.
Sir, how the 12 value is calculated for A from this tree?
Okay, so it actually, you have to calculate that from S to A. If you go, your cost is 3. But then you will see, you discover that you go to D or C, you go to D.
You have to go back. You have to go back to S.
You have to go back, exactly. 6.
So
3 plus 1, 4. And after getting it to D, you find out that there is no way you can go G. So you have to retrace back.
No, sir, 3 plus 3 from S to A and A to S. 3 plus 3, 6.
Yeah. So what? So from S, if you take A, your cost is 3, and A,
Yes.
after taking A, you have to go to D. So your cost is now already 4, right? But after getting into 4, you found out that you can't read G. So you have to retrace back. Your cost would be another 4. So it becomes 8, right? And then again take S to B, then you take 2, and then 1, and then you go to the G. So your entire path cost will be very high if you have taken A by mistake,
Yes, sir.
right?
Yes, sir.
So you'll be
Okay,
highly
sir.
penalized if you go to A, and that entire cost has to be recalculated. Same path you have to come and again reverse back, right? Now
Okay,
there is a
sir.
specific strategy to do that. So I am not trying to impress on you that how the algorithm works. If you are interested, look at the YouTube videos. There are very good YouTube videos how the heuristic search works. Please write it down, and you'll be benefited from that kind of videos. Usually we take one class for heuristic search. Search and sort is very important computing algorithms. Let's switch gear. Let's take a completely different kind of example. You'll be actually treated in much more details in the large language models in other classes. But take a situation like this. You are telling a story, and the story is as follows. Tom is a cat. It is a mammal. It has fur. Tom is owned by John. Tom caught a bird, etc., etc. Now, computers are number crunching machines, right? How can I capture this story? Why I would like to capture the story? Because I would like to infer certain decisions from this story, from this content, just like comprehension. You can represent that again using a graph. It's a directed graph with certain attributes. So you see this entire relationship is captured here as if, so here is one node is Tom. What is the relationship between Tom with dog? It's an instance. Tom has a pet, and we call that pet as an instance. Dog has characteristics like it sat on mat, it likes to eat bone, it is a mammal, it has fur, it is an animal. So entire relationship of the story can be captured using these set of nodes. Okay, can I take just 1 minute break, right? I'll come back within a minute. Sorry about that.
Yes, sir.
Please
Yes,
have a
sir.
understanding.
Yes,
I'll
sir.
come
Yes,
back.
sir.
It's all right. Huh?
Okay, sorry about that. So any question? So I have a chat. Okay. Okay. So so these are popularly known as the semantic network. Again, how to build a semantic network? You'll get good video to learn more details about it. But as you can see, here is okay. So here is a story, and here is a representation of the story. So if you have questions on the story, you infer from this relationship. So given a dog, if I ask who is the owner of the dog, I should be able to answer Tom from the semantic network. Is this a mammal? If I ask this question, this network should give me that answer. So this network actually captures the essence of this story. So if I go back to that black box understanding, S is that semantic network. What is X? X is that story. And Y will be typically the kind of questions, answer to the questions that you're going to put in front of the semantic network. And today's large language model, ChatGPT, conversational information, it is handling this kind of network. But you will see that huge network and billions of such nodes, millions of such connections, and again, billions of the weights of this connection. What do you mean by weight? This attribute between these. So look at the arrows. Each arrow has some characteristics, right? Mammal has fur. Mammal is an animal. Now, the computer doesn't have any understanding of what is has. To computer, it would be a number. It has to be a number. So this has to be represented in a set of weights, in a set of numbers. And processing these huge numbers in fraction of a second, when you ask this question to ChatGPT, is what this processing of network does. So you'll be exposed at least a little bit on this idea, how these large networks, huge networks are being trained. Why I am saying trained? Because this is an example of one story. Maybe I have hundreds of stories. So hundreds of such networks has to be combined, right? Hundreds and thousands of such networks has to be combined, and an immediate inference has to be drawn, which is the why in our case. So let's see if the video runs. So this is an example where we are trying to calculate the ball possession of players. So these are the players, the two teams, red jersey team and blue jersey team. Red jersey players are passing the ball. How many times the ball is being passed? So you count the number of pass of team A, count the number of pass B of the team B. And this has to be done automatically. Remember that we need to count these passes automatically. So we call these as a machine learning algorithm. Machine learning algorithm identifies the player, identifies the ball, and identifies or track the path between player A to player B, and count how many such passes are going on. So if I go back to the previous example of a story, so here is that story. The story is given in the form of a game. And this game data is somehow being processed by a computer algorithm. And where these characteristics of the player and the characteristics of the ball are being identified dynamically. So again, I'm just going to give you the idea that the application, because the solution itself is a long drawn, the long overall model that we are looking at. But this is an example that, or a problem similar to this, we work in our institute, some of the cases. You can even map this problem as the same network that we have just discussed. So who is passing to whom? I'm trying to infer that. Who are the possible pass recipient? I can infer that from the network. So let's say I have a previous frame L, I have the current frame R, right? So it's a video running. So I have frame L and I have a frame R. So from the frame L, a player has a ball to whom this player can give a pass. So I can identify those players on the next frame where the ball should go. So I have possible paths, and the possible paths are drawn by these arrows. Each path will have a cost. Just like that, go back to that example of these. Dog has mammal. So dog is a type, is a mammal. Mammal has fur. Mammal is an animal. So just like this relationship, I'm trying to put a number to this relationship. Or even if you go back to this problem, that I'm putting a cost between traveling from 1 to 2. The traveling from 1 to 2 has the cost 8. Or traveling from 2 to 3 has a cost 7. So I'm trying to put a cost here also. When a player passes a ball from the frame L to the frame next frame R. And then you discover the minimum cost path, just like that Ola or Uber problem, who estimates the minimum cost path and assigns a cost to it. Let me wait 10 seconds for after this, so that just to make sure that we are on the same page on the problem or the challenge. Any question?
Sir, here the cost is not done. Cost.
Yeah, so A, L, it's written in the terms of A. A are the assigned cost.
Okay.
So can you think of any, can you think of any cost estimation process? If the player passes the ball to another player, what would be the minimum cost? Which one will you have minimum cost? Some assumption, some mathematical understanding.
The shortest distance.
Exactly. So shortest teammate should have minimum cost, and farthest teammate would have the higher cost, right? So I can calculate the Euclidean distance between the shortest path, shortest person, shortest distance person, and the longest distance person, and assign a cost. If I have opponent players nearby, then I will increase the cost again, because naturally that player would not like to give a pass to a teammate where too many opponent players are sort of opposing that person. So the idea is complex, but you should be able to give a mathematical representation of the cost. So once you have that numerical cost, then it's a shortest path algorithm. Find out the best path. So as if you are trying to predict, it's again a predictive analytics. So as if you are trying to predict where the ball will go before the ball is being passed. So think of the problem like, is it going to rain tomorrow? Same problem.
The opponents are always trying to predict.
Opponent exactly guessing And that's how the opponent players are moving.
Yes.
And
The movement of
player,
the opposite.
right. So it's a game going on. It's a game of mind where the player tries to pass the ball to the best possible minimum cost. Now, if as a machine learning engineer, I'm good at calculating the cost, my algorithm will be good. Just like a human expert can be good, human expert can be bad. So the better the cost we can assign, the best path or a good path can be predicted. So I gave you a simple example, just like that traffic flow example of, or it's a complex problem like this. So given these problems, it may be possible to have a representation where you can represent the relationship with numbers. And once it is numbers, computers are happy to solve this kind of problem through shortest path algorithms. So it's actually again generating a rule. So we talked about two things here. One is knowledge.
If the nearest player has more opponents, then it will be less costly if we move past the slightly less costly if we pass to the farthest player.
Yeah, it may be higher cost. It's a guessing game, right? I'm not saying my cost is absolutely correct, but I'm trying to predict something. I'm trying to predict given a number. So what were the issue we started this discussion? We have the knowledge representation, we have a knowledge base, and we have a knowledge inference. How we are representing the knowledge? Knowledge we are representing using this graph or tree. Decision tree, we did it for the loan. Graph, we do it for this path estimation. So this is knowledge representation. And how the rules are being formed? By finding out the shortest path in this network. That's the rule it is formed. It is getting formed. How the loan is to be given? A rule is actually formed. And based on the rule, based on the network, we do an inferencing. Any question? Let me just skip that. Okay, so this is an interesting project that we did a couple of years back with the largest software company in India. So what is this? What is this picture all about?
A grocery store like Spencer or like that.
Yes, and the products are stacked, right? So their question was that they want to solve is that take a picture and from the picture estimate what are the products and how they are arranged. Okay, so we have a funded project for that. Actually, each of these manufacturers, they will have a contract with these large supermarkets, how the products will be displayed. Based on that, they get a extra financial incentive. Right? For example, if you put egg next to egg, there will be banana, and maybe next to banana there will be bread, right? Next to bread there will be baby diaper. After the baby diaper there will be beer can. So they have a plan, and there is a psychological reason to do that. I mean, they want the consumer to get into the loop. You buy one after the other, and what would be the best strategy for that product display? That's the large teams work on that. Psychologists work on that. Now, is that plan actually getting executed or implemented? This kind of solution can answer that question. You identify the stacks of Britannia, right? So I have a plan how to display the Britannia biscuits. So are these Britannia biscuits really in that fashion displayed? So there is a plan and you comply with the plan or not. So you check the plans. So where is the machine learning or AI comes into the picture? So what is your guess?
Yes, sir. Can I tell something?
Yeah, please. Yeah.
Sometimes when I go to the supermarket,
Yeah.
the healthy item or the less expensive item, they are stacked in the
Last.
farthest. Yes, last. And the healthy and the reasonable items.
Yes.
So the algorithm, generally people want a shortcut path, which comes at the first, they will
Right.
buy it.
Right.
It is the shortest and the
Yeah.
farthest. No, sometimes people don't have that time or energy or wish to go
Correct.
check for the all items and select the best. So
Yeah.
the first order stacking is which gives the profit most.
Yeah. Yeah. So as you can see, I mean, now here it's an inspection problem, whether that strategy is being actually implemented or not. That's what these manufacturers want to see. The stores get additional financial incentive if they follow the manufacturer's idea. Like if the Britannia biscuits is before the Parle biscuits, then it has to be that way. If not, you will be penalized. Right? Now, who is going to check it? You check it through surveillance camera. Surveillance cameras are everywhere. So from the camera, the manufacturer gets the information whether the store actually followed their deal or not. So you can think of these as a kind of an system like this. So there will be a rule. Rule is going to find out where is the rule. The manufacturer has given the rule that Britannia biscuits are stacked in such and such way. Parle biscuits has to be stacked in this way. Kellogg's cornflakes will be after these, etc., etc. So that knowledge base is already given to. Knowledge base is already given to. Now you take a picture. From the picture, you check whether these knowledge base is maintained or not. So you create a rules engine in between. We'll call this entire thing as an expert system. And the non-expert user at the other end is just looking at that result and saying, oh, it is complied, it is not complied. Right? So what the rules engine is doing, our main contribution or the discussion in today's class is to look at that rules engine.
Sir, what is a non-expert user and expert user?
Well, expert user is who is actually going to populate the knowledge base. So it is going to differentiate between Kellogg's cornflakes and Britannia biscuits. Now you cannot do it manually, right? It's not just impossible to do it. And the huge product range. Every day the product packages changes. So it automatically identifies the color of the box. It identifies the pattern, shape of the block, shape of the box. It identifies what is written on the box. All of these are done automatically. So this expert knowledge-based engineer is automatically identifying these features or characteristics, analyzing these characteristics. So analyzing how the Oreo will look like, how the Britannia will look like, how the Parle will look like, how the modern bread will look like. This is done through computer algorithms. Computer algorithms can read that color, can read the shape of the box, can read what is written there on the box. Again, I'm not discussing how it is done, but just believe me for the sake of it. Just like in this case, this player and the ball identification problem. Players are identified, balls are identified, and the box is drawn. These are done automatically, right? No one can sit there and go on identifying manually and then predict where the ball will go, going to go. It has to be done automatically. So the knowledge base is populated by an expert computer programmer who does all this information automatically, and then a non-expert user through a user interface checks, right? Non-expert user has that plan. The non-expert user has the information from the manufacturer that Britannia biscuits has to be displayed in such and such way. And once these knowledge base information comes, this non-expert user just matches between these two plans. If it complies, then it's fine. If it is not, then it will be reported to the next level of the administration or the hierarchy. Is that kind of is that any question so far?
Sir, I was just wondering, for this last problem,
Yeah.
Parle biscuit, identifying a biscuit or a biscuit packet, that means we need very high resolution pictures.
Not so high resolution as well. Maybe I'll have a few slides. I'll come back to that. Maybe if I get time a little bit, I'll show you how we can extract this information. Okay. So each of these boxes are actually taken as a picture. And I mean, almost all of us have a handheld camera, right? Point and shoot camera with us in your mobile phone. So the moment you take a picture, it's quite good. I mean, the resolution is almost like a high resolution.
Sir, here we are using computer vision domain, right?
That's right. Yes, that's right. Yes. So each box will be represented as a matrix. So at the end of the day, a Parle is a matrix, a Britannia is a matrix, a Kellogg's box is a matrix, and as soon as it is matrix, computer is very happy. It is processing a bunch of numbers. So it is trying to find out the difference. Where is the green color? Where is the red color? Right? Where is that Parle symbol? Because these are a bunch of numbers collected together to represent the Parle symbol. So that expert knowledge base engineer is actually identifying these automatically, writing a computer program and finding out where is that Britannia mark, right? So if there is a green and red combination, then it's Britannia. That information, that knowledge base expert is finding out from that matrix. And you should be able to do that very easily, in fact, by looking at the numbers. Because green will be represented by a set of numbers and red will be represented by another set of numbers. Okay.
Yes, sir.
Let's take a little bit different application where more prominent rules are in use. Medical expert system or legal decision support system. So by the way, so we have AI algorithms, we have machine learning algorithms, but please understand, it can never replace a medical expert. It can never replace a doctor. What best it can do is to assist the medical expert or specialist with the additional information which is difficult for him or her to process, right? So maybe you given a radiology, given an X-ray plate, there are thousands and hundreds and thousands of X-ray plates already available. So maybe a computer algorithm can read those X-ray plates, extract relevant information, and give that relevant information to a medical expert to take a final call. Because at the end of the day, the final call is always from the medical expert, is always from the legal expert, right? So I'm differentiating these two domain from this domain, because you can never replace a medical expert. You can never replace a legal expert. But what you can do is, for a legal expert remembers thousands, hundreds and thousands of legal cases. The question is, if I can extract that legal information, concise it, capture it, right? Maybe in the form of rule, and give that rule information to the legal expert quickly, then this legal expert can immediately take a call, a decision, which otherwise it is difficult for him or her to remember or fathom out. There are a huge amount of legal literature available. Similarly, huge amount of medical information system data is available. But how can we quickly process them? We can actually generate maybe a set of rules, if-then rules. So if the, if let's say a simple medical ailment A, so if the ESR value is high, if the cholesterol level is this, and the something else is this, something else is this, then it is this. So clearly a medical expert goes by this if-then else rule. Our intention here as a machine learning engineer, or one who is building that S, is to build that rule from the past cases. So build that rule from the past cases, give those rules to a human expert, and it will complement the human expert to arrive at a better decision-making process. So what the human expert's contribution would be? It would be the next step, the conflict resolution. If-then rules, if-then else rule, or and/or rule can generate conflicts. I gave the example of the birds. If a mammal, or if an animal has feathers, and it has 2 legs, then it is a bird. Bird can fly. Immediately I can give you a conflict that emu is a bird and emu cannot fly. So this resolution, you can present the cases in front of a human expert, and human expert can do conflict resolution. Nowadays, even conflict resolution can be done to a certain extent by AI algorithms, but most of the time, especially for medical domain and the legal domain, it is always lies with the human expert. And then you have rule propagation. One rule fires the next rule, that fires the next rule. A typical AI system can consist of 500 or 1000 rules, and the rules can propagate through the process. So you will see some of the, probably the networks, you will try to understand where they will have this kind of rule propagation system. So I'm trying to identify Kellogg's cornflakes. You can think that to be a series of rules. First, you identify a box. Then you identify a box with blue color. Then you identify a box with blue color with large K written in a particular fashion. Then you identify that it is cornflakes word is written. Then you identify that it's a 500-gram package. Then you arrive at a decision. So you see a series of rules are getting propagated. Right? So rule propagation is an important, and each time you are propagating, you have a conflict. It is a box. It could be Kellogg's, it could be all brand. There is a conflict. And then you say it's a blue color box. Well, then it is only Kellogg. It's not all brand anymore. Now it is a blue color rectangular box. A big K is written, then it is Kellogg. It could be 500-gram pack, it would be 250-gram pack, it could be something else. So gradually you propagate the rule, resolve the conflict, and get into a certainty factors. Each time you may not be 100% sure, just like a human being. So you can actually generate a probability of the decisions. Right? So Again, I'm giving you a big picture. I'm skipping most of the things, but just to understand the process, right? So you discover a blue packet. It is bluish. Therefore, maybe you are 90% sure it is Kellogg, but there is a 10% uncertainty in the process. So you assign a certainty factors along with the rule. Am I clear, at least in understanding and in giving you the challenges? Is there any question? Any thoughts? Any different views?
Sir, all of these that you have explained, this is done by the computers, but this was being done before this term AI is introduced. Like,
No. Absolutely not. These are all part of AI.
okay,
So rule-based system is AI. That modeling of these is AI. So all these, this is, so you can say broadly 3 legs will be the data processing part, a pattern recognition part, right? And so in modern day machine learning. So data science, machine learning, and then you have the pattern recognition part. So all these are AI.
okay.
And the origin of AI lies in 1960s, 65, 70s.
Okay.
And what it is being presented today is the old wine in a new bottle, but of course you have better hardware. The main push behind today's success of AI is you have computers which can process 1 million or 1 billion such rules using a network. Right?
Okay. Sir, nowadays we get to see that different courses are being offered by different universities, like BTech in artificial intelligence or something like that.
Yeah.
So 10 years ago, BTech in artificial intelligence, 12 years ago, we couldn't get to see. We saw BTech in computer science or computer application or software engineering. So
Yes.
someone who's studying computer science, computer engineering, or software engineering, they must have gone through all these things. But why it is that AI has been introduced in this way?
That's because everyone is fascinated by AI. But in a BTech in AI, they had to study the linear algebra. They had to study optimization. They have to study statistics very thoroughly. They have to study data science, machine learning, all those computer science subjects. Plus, you have to study the pattern recognition. You have to study the machine learning. You have to study the the different aspects of pattern recognition. And in Indian Statistical Institute, these are being studied from at least from late 1970s. So pattern recognition was the key area of research in Indian Statistical Institute from 1970s.
Statistics is based on that, I feel like.
Yes, it's a statistical pattern recognition.
Yes.
So what you are looking at, what all I am talking about is statistics at scale. Statistics not with small amount of data, but statistics with huge amount of data. Right. As you can see, all my applications are data driven. Loan application, data driven. Rain example, data driven. All these images that I'm showing are data driven. So you have to work with numbers. Until today, the only challenge that we are facing is that computers can only perform with numbers. They do not know how to handle anything else. So question is, we have to work with the numbers. We have to do mathematical model with the numbers, statistical model with the numbers, and do the necessary human-like inference from that. Okay? So even if there is a BTech in AI, 80% of the syllabus is BTech in CS, plus more stress on this kind of subjects. For example, we have pattern recognition and advanced pattern recognition in two consecutive semesters in our MTech programs. We have AI We have ML1, ML2, machine learning 1, machine learning 2, etc. Computing for data science, we have a subject, 1 semester long, half months. So this is how this entire area is actually being. So one of the earliest AI rule-based system is actually Mycene. Mycene, you can write it down. You should be able to. There is an entire book on Mycene program from the MIT, and their objective uh, was to have a medical diagnosis based on the pathological and clinical data. So give pathological and clinical data to the computer algorithm. Computer algorithms are nothing but a set of rules, if-then rules, right? Right? If the infection is primarily bacteremia, and the site of culture is one of the sterile sites, and the suspected portal of entry is the gastrointestinal tract, then there is suggestive evidence that infection is bacterial. So that's a rule being formed. So in early work, these rules are formed manually. Manual experts form this rule. Now, a large, huge networks form the rule. And these networks are what probably will be exposed to a certain extent in the other classes. Right? So you'll have a book by Buchanan and Shortleaf on Mycene, and you should be able to see many good web pages on this topic. So let me just, sorry, I just wanted to skip some of the details. I don't have much time, therefore. So I'll just show you a few examples. So, for example, I wanted to show that okay, so can you see this object? Can you see this object on the screen?
Yes, sir. Flower,
Yes, sir.
red flowers.
So I'll leave it at that part as a question to you, as an assignment after the course is done tomorrow, maybe next week or so. Think about this problem. This image is given to you, right? Maybe you have captured it through your mobile phone. You can actually give this as an assignment to the students in the class. Can a computer algorithm and a computer program written in C, Java, Python, or whatever, can the program understands what is it? Can do a human-like inference? Whatever was the topic of discussion of my class today. Can the computer automatically understand that this is a chrysanthemum flower? Any take? Can any one of you think of any process?
Sir, if the computer has already programmed of a chrysanthemum, what is the size? What is the petal size?
Yeah, so you will give this assignment to the student. Yeah, so student has to write a program. You are very correct. The way you are moving is the correct method to go for. Please repeat what you want to see from this image.
There should be a pool of data on the flowers that
Yes.
has to be
What
accessed
kind of,
by
yes.
the computer program. So it is going
Yes.
to take all the information from here, and it is just going to tally from that pool of this
So
one.
first
And
it is going to answer your question, first it is going to collect all the information from this image.
right.
Yes, sir.
So as you can see, this is a rectangle, right?
Right.
Yes.
Rectangle or square or whatever. So you have to have a data structure in computer program to store this information. What would be the data structure? Any idea?
Arrays, two-dimensional arrays.
Absolutely right. It's a two-dimensional array. So there will be
Yes.
bunch of numbers in the two-dimensional array, right? So
Yes.
it would be like two-dimensional array, and each array element will have a number. So the number at the periphery will be smaller, it's kind of towards black, and the number at the center will be high.
Right.
So you have to analyze the data in this step-by-step fashion. So you extract those regions which has got high values, because that will give you the central part. You don't know what is it. I mean, you don't know the name of the flower or name of the object. So computer will read these matrix, and then computer will say it's a chrysanthemum flower. That is what you want.
So from this, the data that the computer is accepting, it has
Yes.
to have access to another library where it can compare.
Absolutely right.
Without
Absolutely.
comparing, how it can give the result.
Right,
LCDs,
absolutely. You have to
yes.
compare. So already the computer should have these. So I think I have. So to computer it will be a matrix like this, numbers. Right? All numbers at the central part will be high. All numbers at the outer periphery will be low.
And the specific number combination will give a particular flower.
That's correct. So you will see, if you draw a histogram, a frequency, you will see two hump. Why two hump?
One is for the red, another one is for this darker
Background.
greenish background.
One is for the background.
Hmm.
So you take the hump at the second part, that is going to give you the central part. Right? So in the computer program, you write a kind of a if statement. If the value is greater than 100, then it's the flower part. If the value, so you read each element, right? You read each element of the matrix.
But sir, not only this if statement will suffice, because there are a lot of things which can have this frequency of this color. Because so it has to be like I have to generate the code, that is I am analyzing from a pool of data which is a
Right.
subset of large.
Pool of data is this matrix.
Yes, that has to be compared with something which is a subset of flower, because
I'll
red
come to
color.
that. I'll come to that. But first I look at these numbers, and if wherever the numbers are very high, maybe close to 200, I can say this is the central part, right? For this example, right?
Yeah.
So I would say, let's put 1 if it is greater than 100, and let's put 0, which is the outside. And then I will calculate different features. I'll find out the area, I'll find out the perimeter, I'll find out the position of that central part. I'll call that features, feature 1, feature 2, feature 3, etc. And as you are saying, you compare it with the already stored data. So look at the bottom row. Let's say I have already done these analysis for these set of known flowers. And that what I can do, I can compare the one at the top with all of these bottoms, for which the distance is minimum. I will assign that name to this flower. Is that part clear? That understanding?
Yes, sir.
Others, if you have any question on these?
Sir, what
Please
is
take
stage
this.
1 and stage 2 features?
So maybe in one's first stage, I will compare the color. And next stage, I will compare the area, the perimeter. area of the central part, perimeter of that central part,
That
centroid of the
is
central part.
elimination is going on. Like
It's elimination. Stage by stage, I am eliminating so that I get an exact match between these flower image that I have given as an assignment with the already stored data. And these features that I've already done, so if you look at the slide, I've written model base, right? So this model base is what? Model base is what?
The data of other kinds of flowers which are already saved.
Already stored. That's right. Let's say in this case, I have
data
one.
of all flowers, the data of all
Say
flowers.
5 or 100 flowers I've already
Yes,
analyzed,
yes.
and I kept it in a Excel file. I kept its color information. I kept its mean color, average color information. I kept its area. I kept its perimeter. I kept its centroid, etc., etc. This is my model base. This is my knowledge base. And an unknown flower comes in, which is shown at the top right. This is the chrysanthemum. I don't know whether it's chrysanthemum or not. I will calculate the same set of features from the chrysanthemum. And then I will compare with these model base, each one of them one by one. And I know how to compare. How to compare? How to compare?
Comparing between numbers. What
Yes,
I get
it's just a distance calculation, Euclidean distance.
Yes, yes.
And for which the distance is minimum, I'll say, okay, it is that particular. Right?
that's to find out the close
Yes.
match.
Closest match,
Right.
yes. There could be conflict, just like a human expert can have a conflict. Human expert may not be sure, 100% sure. So there could be conflict as well. But this is how the process can simply work.
Basically,
You can actually
how
give these as
think
an assignment to the students. Yes. I'll stop it here, but if you have any questions, let me just spend a minute or so. Any questions, any issues? I'm not sure how far I could transfer the knowledge, but
Sir, we have used ChatGPT for long, but we don't know the real mechanism going on. Today we have a good.
You have a class on LLM, right? So
yes.
Exactly. So this is the basic based on which they will build on the large language models. They will show you how these networks are being trained. So in this case, I show an example with a flower, but if I take you to that example of that story that I'm capturing through a semantic network. So huge number of such semantic networks are being trained or stored in the computer. And you process that network. Process in the sense that you ask question to the network and you get a result out of it. That's what will be discussed in detail in the large language models and other classes. Often these kind of problems we call as a classification problem. These flower identification problems are called the classification problem. Classification, because an unknown flower image comes in and you want to identify, you want to know, is it a chrysanthemum flower? Is it a rose flower? So it's a classification algorithm, and you will be exposed to those classes of classification. There will be some discussion, automatic tool to do these classifications. There will be visualization issues. I talked about the features, 2-dimensional features, 3-dimensional features. If there are n-dimensional features beyond the 3-dimensional, then how to visualize them? so that you can fit a line or fit a curve or fit a surface, etc. Any question? Comments?
Sir, these all are supervised learning, right?
This is called the supervised learning. Supervised in the sense,
yeah.
supervised in the sense that you are assigning a label, a name, that it is a
Yes.
chrysanthemum flower. In
Yes,
fact, unsupervised learning to some extent could be a sort of subpart, is part of the supervised process.
Yes, because pattern recognitions and these things is coming under the unsupervised also.
No, absolutely not.
Then what
includes both.
what is the actual difference then?
There is, these are the different branches. So there is an unsupervised clustering, we call it. It's not classification.
Yes.
So pattern recognition includes both supervised and unsupervised. For example, there is a group of animals, and I discovered that there are two groups of animals. So we call that as a clustering problem. That's the unsupervised. We are just saying there are two groups of animals. Now, if I say that there are two groups and one group is cat, one group is dog, then that's a classification problem.
Yes, sir.
That's a supervised problem, because you are assigning a label, a name to the cluster.
Yes, sir.
Now, there is third thing which is very prominent in pattern recognition, that there is something called syntactic pattern recognition. For example, English language, right? You interact with ChatGPT. ChatGPT creates a English language like construct, so it can understand the grammar. Grammar is a pattern, right? He is a good boy, she is a bad boy, a bad girl or something, is, are, etc., etc. So there is a specific pattern to it. So you can have a pattern. That's the third part, which is, we will call that as a syntactic pattern recognition, where there is a specific grammar or rule informing that. So we touched upon almost all, but we didn't actually go into the details of clustering, which is basically a subpart of classification. Any other question?
So the example that you gave, like this clicking the picture, and then what we are trying to find out is what type of flower is it. Now, what the computer is doing, computer is taking the picture and storing it in a double dimensional array, and it is comparing the data with another.
It's a classification problem, because it is labeling.
Yes. Now my question is, artificial intelligence, like while using ChatGPT, I have seen, like when I'm giving any kind of information, it is asking for more information, which I'm giving it, and it is storing it. It is keeping it like saved. Like so it is.
So go back to my example of that Tom is a cat, etc. That semantic network, right?
Right.
Now you see, you are doing a conversation, means it is actually creating that kind of network.
And it is storing it as well.
It is storing, it is manipulating, and it is inferring from that. You are asking questions, and maybe a part of the two nodes and its connection is coming out as an answer. So that understanding that kind of data structure is very important. So see, there will be classes on LLM, chat, or similar such things, but you have to go back to the basics first. You have to really understand the data structure, array, then these linked lists, and then the searching algorithm, heuristic search, path estimation, shortest path estimation problem. So these are basic tools, because at the end of the day, these problems will be mapped to that number crunching computing algorithms, right? So you have to work with that. Now, you will be exposed to large network. What happens with the large networks is that these are completely intractable. Now, the example that I've given, maybe have 10 nodes, 15 connections and ages, etc. But when you, in the afternoon, when you look at those classes, they will talk about 1 billion nodes, right? 50 million connections between them. And that's why there is, I raised that environmental issue, because this is such huge architecture. For example, if it is unfortunate, but there is, I mean, I can say for sure that India doesn't have its own ChatGPT-like system, because we don't have that hardware infrastructure where you can train such a system, where you can generate that kind of network. We all work with the network built in either in Europe or in US, because we do not have the infrastructure. So currently the government of India has a large scale project where they're building this kind of network. But we don't have. Why we don't have? Because we don't have that computing infrastructure to process that 1 billion nodes, 50 million connections. And we are thinking about the few billions of data points, right? That's just so what we do, someone else has done the network, someone else has created the network, we download that network and we retrain it for our problem. We use it for our cases. That's very unfortunate, but that is true. Maybe down the line, next 4 or 5 years, we should be having our own conversational generative AI platform, our own ChatGPT in India. Yes?
Sir, excuse me.
Yeah, please.
Sir, actually, I was traveling, so I've missed a lot of your wonderful class that you've taken. It was really wonderful. The little that I was coming from Jamshedpur.
I think you will get.
I heard.
Yes, I think you will get the recording or something. You can get.
No,
I don't know. I mean,
I've gathered. I was
yes,
really
a recording
perplexed.
will be there.
Yeah. Okay.
Yes. Okay. Sir, I was trying to say that there is a lot of scope, sir, in the future where ChatGPT is concerned in India. That is what I feel, isn't it, sir? Because
yes,
you said
yes.
There is no, yes. So, and what about application in economics, sir? How would I do it? I mean, sir.
Well, that's a very general question. I mean,
of course.
For example, just a few days back, we submitted a project from these IDEAS TIH to have a GDP forecasting model.
Okay.
So how can I forecast GDP quarter wise?
Okay.
So government of India forecasts GDP, right?
Achha.
And so can we have a better model to forecast GDP? Actually, we worked. Our group worked moderately on this problem and then submitted a research project so that we can have a better model to predict the GDP.
Achha, sir. Okay. So, sir, it is very much connected to forecasting, isn't it, sir? Data is there.
Yes. And the term now comes is called nowcasting. Nowcasting means nowcasting immediately.
Okay.
You don't wait for prediction of 1 year, but predict it within next 1 month or so.
Within minutes, it's done. Okay.
Yes. So nowcasting problem.
Okay, sir. Nowcasting. Okay, I learned the term. Thank you so much, sir.
Yeah.